Alright guys, this is our last official video topic. Last official topic of the semester. I will teach one more topic to prepare you for calc, but this is the last one. So that's 7.5 is also trig equations. They're harder equations that we don't have to do this semester. Alright, so here's the main fact. If you know what sine of theta equals, so if they tell you sine of theta equals whatever, then you know what theta equals. You can figure out what the angle is. Okay, so we're just going to jump right into examples. So if I want you to solve, okay, and remember, solve means what value or what number or numbers make a true statement. Anytime you're solving any equation, whether it be trig or anything else, what numbers make a true statement. Okay. Alright, so if I wanted you to solve sine of theta equals 1/2. So this is what the statement is saying. If you know what sine of theta equals, and in this case it's telling you that sine of theta equals 1/2, then you can figure out what theta equals. Okay, so that statement is saying, so we're kind of thinking a little bit backwards here. This is saying what angle theta, because remember you always plug in angles into trig functions, or famous pi guy, okay, has a y value, because sine is y, equal to 1/2. Okay. So we're trying to find what angle has a y value that equals 1/2. So where do we find that at? The unit circle. Alright, so if we go to the unit circle, which pi guy has a y value of 1/2. So we already know the pi over 4s and the pi over 4s. So it's either the pi over 3 guy or the pi over 6 guy. So what's pi over 6? What are those coordinates? Square root of 3 over 2, comma 1/2. So what's this guy? It's the pi over 6. Okay. So theta is the pi over 6 guy. So theta equals pi over 6, because if you plug that in, sine of pi over 6 equals 1/2. And that's a true statement. So it was the pi over 6 guy. But somebody should be thinking, but wait a minute, Sam, what about this pi over 6 guy? Which pi over 6 is that? Yes, that's 5 pi over 6. That also has a y value of 1/2. So we could possibly have more than one answer. But theta equals 5 pi over 6 also works. Okay. So there's two solutions. Okay. What about this guy down here? This pi over 6 guy. 7 pi over 6. Nope, that's negative 1/2, so that doesn't work. Same thing with this pi over 6. That's negative 1/2. So that guy doesn't work. Okay, so if you go one time around the circle, let's write this down. One time around circle, one period, okay, / rotation, you get two solutions. Theta equals pi over 6, or theta equals 5 pi over 6. Okay, so those are our solutions. Right, these are called primary solutions. That's going one time around the circle. Okay, they're called primary solutions. So the directions here weren't specific. You didn't say primary or all the solutions or whatever. I just wanted you to get the idea of what angle would make this equal 1/2, and angle of pi over 6 or the angle of 5 pi over 6 will give you a true statement. Alright, so those are your two solutions. But what if we kept walking around the circle? Okay, so what if we did more than one lap? We just kept walking. We would hit this spot more than once, and we would hit this spot more than once. Okay? So there's infinitely many solutions. To get all of them, there's a way we can write them. Okay. We add 2 pi k to the solutions. Okay. We add 2 pi k to the solutions. And I'm going to explain why. Okay. So these are our primary solutions. Those are when you go one time around the circle, those are the only two angles that give you sine is equal to 1/2. Those are called your primary solutions. Okay. But if we want all the solutions, okay, we add 2 pi k to the primary solutions. Okay. And I'm going to show you why. I'm going to show you what that means. So depending on the directions, you could either just give those two, or if it says find all solutions, you could write it like this. Okay. It said to add 2 pi k to each of these. Okay. So pi over 6 plus 2 pi k, or 5 pi over 6 plus 2 pi k. So what does that mean for pi k? And guys, I need my coffee. Alright. So let me tell you some information about this 2 pi k. So 2 pi, that represents going around one full circle. Rotation. Okay, so 2 pi is the whole distance around the circle. So if you walk 2 pi distance, you're always going to lap it, okay, no matter where you start. So if you're at pi over 6 and you walk 2 pi miles, you land back at pi over 6. That's one full circle. If you're at 5 pi over 6 and you walk 2 pi miles, you walk one full circle and you land there. So that's what the 2 pi is about. Okay? The k equals the number of laps forwards or backwards. So remember, you can go backwards too. Okay. So you could walk, again, start at pi over 6, walk 2 pi, your normal counterclockwise rotation, or you could walk negative, you could go backwards and walk 2 pi, but in the opposite direction and still land on pi over 6. So k is any integer. So plus or minus 1 lap, plus or minus 2 laps, etc. Okay, so that's what that k represents. And you just keep landing on those same spots. Okay? So these would represent all the solutions. That's how you would write all the solutions. You would rewrite them as pi over 6 plus 2 pi k, 5 pi over 6 plus 2 pi k. And you literally leave the k, because k can be any number, however many laps you want to land back at those two famous spots. Alright, let's sink that in for a minute. Just FYI, the book might show different ways, especially for tangent. But you can always just do 2 pi k and you're fine. And you will be alright. Alright, here's B. So same direction, solve cosine of x, or x, theta, whatever you want, doesn't matter what variable, equals square root of 2 over 2. So again, this is saying what pi guy has an angle, what pi guy, what angle has an x value equal to square root of 2 over 2. So we'll go to the unit circle. And this one should be easy, right? These are the easy ones. The square root of 2 over 2 is the pi over 4 guy. And you want the x value to be square root of 2 over 2. So it's pi over 4. So x equals pi over 4. Are there any more answers? Remember, it's always got to be all the solutions. Okay. And again, I wasn't specific, but we'll write both out, the primary and the all the solutions. So in one left you got pi over 4. What about this pi over 4? That's 3 pi over 4. What's that? What are those coordinates? Negative square root of 2 over 2. So you want positive square root of 2 over 2, so that guy doesn't count. So which other one? This guy has positive. So which pi over 4 guy is that? 7 pi over 4. It has a positive x value of square root of 2 over 2. So x equals 7 pi over 4. So remember, these are your primary solutions. These are one rotation around the circle. So you got to at least have these. If they ask for all solutions, you would take your primaries and add 2 pi k to each. So here are your primary, and there's your all solutions, whatever they may ask you in directions. Now, since we're not officially learning trig inverses, we can only deal with these famous x and y values, these famous outputs. So otherwise we would have to learn how to do other non-famous ones, but that deals with trig inverses, so we don't have to worry about that. Alright, let's do another one. They do get fancier, but I just want you guys to get the idea of how to think about these. You're kind of thinking backwards. There's C. This gets a little fancy. 2 tangent of x equals 2 root 3. Now tangents take a little bit more work, okay? So just like other examples of equations, let's get trig function by itself. Okay, if you can do that, get the trig function by itself. So I'm going to divide both sides by tangent of by 2. Remember, it's an equation. I can do whatever I want as long as I do it to both sides. So it just simplifies to the square root of 3. So now, which pi guy, or guys, there's going to be 2 solutions in general. Not all the time, but you want to make sure you get them all in the first walk around the circle. Which pi guys have a y over x, right, equal to square root of 3. This tangent is y over x. Alright, let's go in the unit circle. So we know it's not the square root of, or the pi over 4s, because that's square root of 2 over 2, and that's where tangent is 1. So it's either the pi over 6 guy or the pi over 3 guy. And we have, what is this? Square root of 3 over 2 comma 1/2. And 1/2 comma square root of 3 over 2. Alright, let's work these out and see which ones give us square root of 3. So remember, we're looking for y over x. So y over x. So for the pi over 6 guy, that would equal y over x multiplied by the flip. That gives you 1 over root 3. It's not that one. We want square root of 3 to be on top. So it's not that guy. So pi over 3, it's got to be this guy. So we want y over x. And this y is square root of 3 over 2. Multiplied by the flip. 1 over 2. Sorry, 2 over 1. That's what I get for doing it in my head. Let me not do it in my head. Oh, look at that. Square root of 3 over 1, which equals square root of 3. So it's the pi over 3 guy. So, x equals pi over 3. That's the angle that gives you tangent equal to square root of 3. But what's the other pi guy? Pi over 3 guy. So what is it? This one? That gives you a positive and a negative. This gives you a negative, and a negative, which gives you a positive. So which pi over 3 guy is that? 4 pi over 3. So x equals 4 pi over 3. Those are your primary solutions. And again, if you wanted to do all solutions, you would add 2 pi k. And again, the book, especially for tangent, does 2 other ones. For tangent does a different, it is just pi k, but don't worry about all that. You can study it if you want, but 2 pi k will always work. So those are all your solutions. Okay. So again, just remember this guy up here. What's this guy? 2 pi over 3? So 2 pi over 3 is not a solution because tangent of 2 pi over 3 equals negative root 3 when you do that math. Okay, because this guy is negative in one of them. Okay. So there's a tangent guy. So we got our tangent by itself, and then we went to the unit circle. Okay, so you can get that trig function by itself and then go from there. Alright, let's do another one. There's D. Cosine of theta equals 4. Okay. Alright. Cosine's by itself. And it doesn't matter what variable you use. It's variable just represents any number that makes that true statement in any equation. So theta, x, y, t, z, doesn't matter. So what pi guy, or guys, give you an x value, which is cosine, of 4. So if you go on that unit circle, so which one of these famous guys? You should be thinking none of them, right? They all equal, so those x's are what? Square root of 3 over 2, 1/2, or sorry, square root of 2 over 2, and 1/2. Those are your x values. You might be thinking, well, maybe Sam, it's not famous. If it's not famous, we draw angles, talk about trig inverses, but we're not doing any of that. Here's the deal. A long time ago, I told you cosine and sine are between, what's the biggest value? The biggest value is 1, for either of them. And the smallest value is -1 for either of them. That unit circle does not go beyond that. You can't get bigger than 1. You can't get bigger than -1. So sine and cosine are between -1 and 1. Okay? 4 is bigger than 1. Now tangent, cotangent, cosecant, all those can be bigger because those have flips and those turn out to be bigger 1. But sine and cosine are restricted. The biggest values that are coming out are either 1, smallest -1. So this guy is no solution. So be careful, don't get tripped up by this. No solution. Can't be bigger than 1 or smaller than -1. No matter how many times you go around that. No matter what, famous, non-famous. Even if you go in between, you're going to get decimals smaller than 1. Never bigger than 1, never smaller than -1 for sine and cosine. So be careful. No solution. Alright. Let's get a little fancier. What was that? D? Here's D. 2 sine squared theta -1 equals 0. Alright, so get trig function by itself. Okay. Alright, so I'm going to add 1 to both sides. Okay. Then what? Yes, divide by 2. Both sides. Okay. And literally get it by itself. Square root both sides. Square root both sides. Okay, if we square root both sides, because remember, this is the same thing as, remember that square there is the same thing as that square there? Okay. Square root both sides to get rid of that square. And don't forget what, ladies and gentlemen? Yes, plus or minus. Plus or minus. Do not forget that. So you have sine of theta equals plus or minus, and I can give the root to each of these because it's division, plus or minus 1 over root 2. Okay, so we got the trig function by itself. That's what you want to do first before you head to that unit circle. Added 1, divided by 2, and then I square rooted both sides. Don't forget, when you square root both sides, you have that plus or minus. And then I simplified square root of 1. Square root of 2 doesn't simplify. You might be looking at that number like, crap. 1 over square root of 2, that's not on the unit circle. If you think of your x values, or sorry, your y and x values, where's there a 1 over square root of 2 in these guys? Okay, so I'm going to clean it up a little bit. We can rationalize this. This is one of the only instances where rationalizing actually helps. So you can see what other kind of number it looks like. So when you rationalize, you multiply the top and bottom by the same root. Okay. You multiply, you get square root of 2 on top, and the rationalizing takes the root out of there, so you just get over 2. Oh, that is one of our famous guys. Look at that, square root of 2 over 2. So that is your pi over 4 guy. Okay. Now this has 2 answers though. So we want sine of theta to equal positive square root of 2 over 2, or sine of theta to equal negative root 2 over 2. So we got to find where both of those things happen. Okay. So theta equals, for positive, pi over 4. That's the first spot. And the other positive guy is 3 pi over 4. Okay. So those give, so we're sine theta equals square root of 2 over 2, so y equals positive square root of 2 over 2. Okay. And then down here, I'll do it in a different color. This is 5 pi over 4, 7 pi over 4. I'm just writing down my coordinates. This is where sine of theta equals negative root 2 over 2. So y is negative. So that is theta equals 5 pi over 4. And theta equals 7 pi over 4. Okay, so all 4 of those solutions must be listed. These are your primary solutions to our equation. So our equation ended up getting a square root. 2 of those equations broken down, each of those got 2. Okay. So you got to list all 4. 2 for that guy and 2 for that guy. Okay. And again, if you wanted all solutions, just add 2 pi k to all 4 solutions. Those will give them all to you. Okay. So that guy was a little step up. One, we had to get this sine function by itself, and then rationalizing to see our famous output there. So we got the root by itself, or sorry, the trig function by itself. Adding, dividing, square rooting, don't forget your plus or minus. Simplified that root a little bit. Then I rationalized to see what this 1 over square root of 2 really looks like on our unit circle, which is square root of 2 over 2. And then I broke it up to get the positive values and the negative values and found those pi guys. Okay. And so they just start to get more difficult and difficult as they go. Not like craziness, but just fanciness here. Okay, fanciness here, so we can break it down to one trig function. Alright, let's do another one. Be really thankful we get to skip those ones that are nasty. Very thankful. Alright. Oh man, you're gonna hurt me for this one. Oh, there's... Okay. Sorry, I'm thinking out loud over here. Sine squared of x minus sine of x minus 2 equals 0. There we go. See, I told you they get fancy. Okay. Trying to get one of these trig functions by itself, that'll never happen, right? Like it's this minus 2, like it's never going to happen. So we're going to have to go and solve that. Okay. Now, there are 2 ways to go about this. Okay. Anytime you see an exponent, what should you do, ladies and gentlemen? You should factor, right? Set it equal to 0, factor 0. You could totally start factoring right now. It's kind of weird because you got sine of x. But you could do it. Or if that looks too weird to you, you could use u sub and go from there. It's up to you. Okay, so I'll show it both ways. Okay, I'll show it both ways. So if I did I'll do u sub first. Let u equal, what are you going to let u equal? Sine squared of x or sine of x? Yeah, sine of x. And when you square both sides, you get u squared equals sine squared of x. Now, careful. The sine is squared, not the x. Okay. So when we do u sub, get u squared minus u minus 2 equals 0. It's equal to 0. Now we can factor. God forbid we have to use quadratic formula. Make sure you factor right. U minus 2, u plus 1. U equals 2 or u equals negative 1. Okay, and remember in u sub you are going to have to go and find your x. So we're going to use this guy. U is equal to sine of x equals 2. Okay, and or u sine of x equals negative 1. Okay. Alright, where is sine equal to 2? Never. Okay, remember it cannot be bigger than 1, smaller than -1. So that guy has no solution. Alright, where is sine equal to -1? Let's go in our unit circle. So what pi guy makes sine equal to -1? Well, here sine is +1. That's pi over 2. I want sine equal to -1. So that pi guy is 3 pi over 2. And notice for this guy, there's only one solution. Okay, there's only one primary solution. That's fine. So x equals 3 pi over 2. Only one primary solution. And the other equation we broke it down to did not have an equation, or did not have a solution. Okay. If you wanted all, then you would do 3 pi over 2 plus 2 pi k. The directions would be specific. Okay. Oh, let me make a little note. So note. Okay. If the directions say find all solutions, means find them all. If not, it says it'll say between 0 and what is this next? 2 pi. So this means one lap around. You start at 0, so start at 0, go all the way around to 2 pi, but don't count 2 pi again. That's why there's no equal sign. This means primary solutions. So if the directions say between 0 and 2 pi, that means primary solutions. That's one lap around the circle. So it starts at 0 and it counts that answer if it needed to. Goes all the way around, counts all the other spots, but it does not count that 0 or that 2 spot twice. So it counts it once, but doesn't count it again. So that's one lap around. Okay, so that means primary solutions. Directions could give you that too. If it wants all solutions, it'll say find all the solutions. Okay. So u sub, so we have this crazy x squared thing, couldn't get one of the signs by itself, and then solve from there. Let me just show you real quickly. You could just factor right away. If you're comfortable with it, if you see it, that's fine. So factor right away. You don't have to use u sub if you don't want to. That would be sine of x. So what times what gives you sine squared? Sine times sine. So sine times sine. What times what gives you -2? -2, +1. So there's your factors. So when you have it factored, you set both of your factors equal to 0 and solve. So you didn't necessarily have to use u sub with this problem, but factoring might seem a little weird to you, factoring with signs. It's up to you. And then from there you get the signs by themselves. And you end up back where your u sub is. Okay? And then you go. Okay. So you could have done it either way. I'm just giving you options for that. Can you let that sink in? What time is it? 34. I'll leave it at that. It's a 35-minute video. I might make one more video over the weekend just to do more examples, just to see a little bit more complicated examples. They don't get super complicated. A lot of it is factoring. Or maybe do some examples in office hours with people, and that'll be like our last official videos or whatever. So more examples to come with this. I just want to stop this video right now. It's already at 35 minutes about. We write our final solution. Yep, there we go, over there. Okay.